Welcome to Sip of Science, the virtual coffee break provided by VTT. My name is Jussi Manninen. I work for VTT, and our today's headline is Egg Without Chicken. Is it magic, or are we on the verge of a new industry? And today I'm actually joined by two experts, one representing the academia, the research, and the other representing a startup company. So let's introduce our panelists. If you start, Emilia, first.
Hi, I'm Emilia Nordlund and I'm leading a research team called Food Solutions at VTT. So researching and developing food innovations is really on my agenda every day. And at VTT, the topic of today, biotechnology in food production, it's really in the core of our research strategy at the food research. So I'm very happy to be here today to talk about the topic.
I'm Pasi. I'm CEO of Cellular Foods. Cellular Foods is a spin-off from VTT, and in my previous life, I used to be a researcher at VTT as well, but now working for the company.
All right, thank you. Actually, today is the first of a series of presentations that are actually concentrating around the topic of or the exponential list of hope, which has been published by VTT and our CEO Antti Vasara. So we are talking today about biotechnology in food production, and it's on the list. It's actually first on the list. Why is it on the list? I mean, why does it deserve to be on the list?
Well, at least from the company perspective, global perspective, and a humankind perspective, it is very important. On higher level, if we think of, for example, greenhouse gas emissions, on a higher level, the division of global emissions from different sources is quite simple. About 75% of greenhouse gas emissions are due to the energy, what we use, how we use, what kinds of energy, basically fossil fuels, and 25% is due to what we eat. And there are actually technologies to change the energy system carbon neutral, but not really technologies in place and solutions in place to turn food system carbon neutral, even carbon negative. So that's one. But then I would say agriculture and food production goes even beyond that, because it's a child of multiple problems. The agriculture system uses about 70% of the fresh water used on the planet. And there's a lot of pesticide use. We in the agriculture sector, we use here almost only on daily basis news about the extinction of species and a loss of habitat of insects and other animals. And that's the second one. Then if we look to the sea, the global wild fish or wild marine catch was 20 years ago. Since then, the wild catch has been declined, and basically about 20 years ago, hardly the industry called aquaculture existed, or the supply from the global marine catch was very small. But now it's about 50%. And land use is maybe another one for the agriculture sector. About 50% of the globally arable land is already used by agriculture. So if we want to produce more food for the increasing population, where do we get this land to provide all those calories?
I think it was quite a thorough list of things that there is not really any option to continue like we are continuing today, that we really are in the place that we need to change the way we produce food.
So at least for me, it's kind of a surprise that actually the choices that I make on my plate have such a big impact on a lot of things. And obviously, when with the lot more sort of a hungry mouths to feed, I guess we're actually sort of solving one of the great problems of the mankind. But I mean, for me, cellular agriculture, biotechnology, and food production doesn't really mean much. Could you explain our viewers that what are we actually talking about here?
So yeah, this is a good thing to go back to the basics and really explain in practice what do we mean by cellular agriculture or the biotechnology in food production. There are many ways to name this rather new concept, although there is also quite long history with it already. But basically what we are talking about is that we use single cell organisms, microbes or other cells, and bioreactors instead of animals and fields to food production. And when we talk about the bioreactors, maybe an example for everybody to think about it, that we could benchmark against the large scale breweries, really. So how we are brewing beer nowadays, I think the tanks, the fermenters look pretty much the same what we are here referring to bioreactors. And really these single cell organisms, they can turn various different feedstocks into complex food products. And here you can see a very simplified version of the process scheme, in a way, what the cell factory for food means. So in addition to the feedstocks that can be glucose or various side streams, we need, of course, energy to keep the bioreactors up and running, and we need water for the system, and of course we need the industrial biotechnology to make the system work. And I would like to emphasize that the cellular agriculture is actually very versatile. We can produce very many different products, and here you can see the division to two different categories. We talk about cellular products, or then we talk about acellular products. And what does it mean? So cellular products are products that we use as such as food ingredients, meaning that we use the whole cell mass that we get from the bioreactors in a simplified manner as a food raw material. This can mean microbial biomass, single cell protein. This can be cultured meat or cultured plant cells. And maybe to give some examples, so what are how these cellular products are applied. The microbial biomass or the cultured meat, of course, the target is really to replace meat, so to provide meat alternatives. And there is, of course, the Pasi is here from Solar Food, so that's a good example, and you can hear later on about they process a bit more and product a bit more. So, but then there is also already quite long has been on market a product corn that is really about this cellular product. So I encourage you to test that if you have not yet tested it. It's quite broadly at the food markets already. Then the plant cells, of course, that's not for the meat analogs, but it's really to make new vegetable-based food innovations and really targeting maybe producing vegetables, fruits, berries that cannot be grown at a very sustainable manner at the moment. Let's say avocado or cocoa or some rare berries or fruits. Then we have the other part, the acellular products. So there the target is not to use the whole cell mass or the biomass, but we really separate the components we are interested in from the cells, let's say microbes. And here we engineer the microbes or cells to produce, let's say, proteins or lipids or some other interesting high added value components at high concentrations, to say. So this is also a technology actually that has been used quite long already, and also in food industry it has been used for production of vitamins or flavorings, for instance. But now I think the new thing really here is that we start producing bulk proteins, well maybe not bulk proteins, but nutrients, and let's say animal-based proteins, dairy proteins or dairy lipids, or egg proteins. It was also in the title of the whole session. So that's really the new thing. But this is now this in very short. I could talk about this for a long time, but in short, what cellular agriculture concept is. But I would like to now give the word to Pasi, maybe to tell about your case and how does it sit in this scheme here. Go ahead.
Yeah, we took the decision to use a non-modified organism. We thought that the go-to-market is easier, especially in Europe. In the US, Asia, it's a bit different, legally speaking. So that's one framework. How what's the legal setup and permitting process and go-to-market lead time there. And what we are doing simply is basically all the heavy lifting happens by the cell. So we are using a single cell or actually a bacteria screened from environmental samples that we just grow in a fermentation process. What is different and new, and then what gives us all the positive environmental impacts in Solar Foods case is due to the fact that our microbe does not eat sugar. So for the energy and carbon source, we don't use sugar or any other agricultural product, but we de-link from agriculture and aquaculture when we feed the organism, and it can utilize as a source of energy hydrogen that we make with electricity by splitting water. And the source of carbon is carbon dioxide. It's the same as plants do, although we do use technology to separate carbon dioxide and provide condensed streams of hydrogen into the reactor and CO2 as well. And then the organism just grows. You also need to provide some nutrients in the media, including nitrogen source. But on mass balance wise, energy wise, environmental impact wise, they are minor. But the important thing is where the electricity comes from. And then the organism just grows, multiplies. You continuously remove the product liquid, dry it, and you end up with a powder that, in simple terms, it's almost identical to soy, I would say. It's a complete protein, about 65% carbs and fats. And then this can be used as an ingredient in different food products.
Okay, so I was just going to ask you, where do you actually see the market that is going to be in the sort of food industry, or is it also suitable for feed? I guess also a lot of the sort of agricultural land is harnessed into production of feed for example, production animals and such.
Yeah, it's true. Actually, if I can remember correctly, about half of the calories that are grown go through the animal to the food system. So basically, it's for feed, roughly speaking, somewhere there. So animal feed, chicken, pork, or fish meal is something what we are asked a lot. We could do it equally, no problem. Actually, the permitting is faster and easier, lighter in that sector. But then you are also talking about an ingredient or material that is about one order of magnitude lower in market price. So instead of 15 euro, you might get 1.5 euro dollars per kilogram, and it's not good. So therefore, we aim at for high-end human consumption. That's one. Then the second thing, how it's used, is that it can be used as a food ingredient where proteins are used today in different kinds of ready meals, backed soups and stuff to bring some function or nutritional value. Then cultured meat and dairy. So if we do really replace meat texture, real meat with plant-based alternatives that have some functionality and texture resembling meat, then you also need the nutritional value of meat, and that is what we can provide in the ingredient. And then forward to the future, what we are also developing is growth media for the cultured meat industry in the longer term. So if we replace all the cows by cultured meat factories, then we need to produce a lot of feed, not for the cows, but for the cell factories. Yeah. So we're also looking at that.
Okay. That really sounds really exciting. And I guess just to make a clarification for the title said egg without chicken, I guess we are not producing eggs in these reactors, but just the ingredient or the egg protein. which is then used in different baking products.
Yeah, that's the simplification in there. It's quite. It would be well. It's not impossible, but it would require quite many compounds to be produced in the cell factory, and then some texture design also to make egg. But yeah, it's really we are talking about the key ingredients, protein ingredients or lipid ingredients that are in the eggs or dairy milk, let's say cow milk or so on.
So basically, we can still enjoy our egg in the morning, but in the baked products and such, we could use such an alternative, and it would be virtually indistinguishable from the product to say that it's being produced this way or that way, I guess. So from the
Yeah.
consumer point of view, it tastes the same, looks the same, and just get a better conscience when consuming such a product.
Yeah. Yes, and I think egg proteins are are very interesting case in that way because maybe not all the consumers even know that egg proteins are dominating the food protein ingredients market because they are used in so many places. In the bakery products, that's quite obvious, but in many places because egg proteins are so sort of functional, they are so good from nutritional point of view, but also the techno-functional properties. So it's a very key ingredient for the food industry. So that's why very important.
So basically, we started with the notion that saying that the way we produce food is not sustainable on the long run. And while Pasi's all right, welcome back.
In the case of egg, it's important to understand that there are two primary aspects how you should look at the foods and materials what are produced there around the blue circles in the slide. One is that there must be some nutritional value and benefit in different forms for in this case human body. That's one. And then the second is functionality. So in the case of egg, it's a material with a very specific functional property, which means functional property means that how it works in different kinds of foods and does it provide texture or strength or gel or something like that. And that is something what you also need to bear in mind. And egg is very specific there.
Okay. So if we sort of started this discussion, that I hope that this gave a sort of an overview what we are talking about here, what cellular agriculture or using biotech in food production is about. We start with the actually the need or the sort of the challenge that the way we produce food these days is just not good for the planet, and I guess also our diets are not necessarily good for us either. Are there any? I mean, what are these sort of? If we sort of recap the sort of benefits now that we get from these type of concepts. Obviously, the environmental part was one, but are there any additional benefits that you get from this new type of food production?
Everybody can see all the benefits, or maybe not even all listed here, but some that we can state, and maybe still about this ecology or environmental benefits. Of course, that's something that is questioned also many times. That is it really that much better then, because we need the energy and water and feedstocks and all these fancy tools. But I must say, if we continue still a bit with the egg without chicken case, that we have actually compared and calculated together with our partners at the University of Helsinki, that the greenhouse gas emissions, for instance, they are 75% less compared to the farming chickens, or when we produce the egg protein in cell factory. And regards to the land use, we would use actually 90% less land compared to the farming chickens. So it's really a huge the environmental benefits. But then, of course, when we talk about yeah.
No, I was just going to ask Pasi if they've done actually a similar type of comparison. That how does your process and product
Yeah,
compare
we
to?
have actually. And these days, it's good to acknowledge that if you go to any food producer, so in our case, as Solar Foods plans to be a B2B ingredient provider, so you go to food producers who make the consumer products. That's one of the first things they ask. So can you scale? Is there economic feasibility? And what's the environmental performance? So that's a top 3. And and they are kind of equal there. So you need to have that figure as a startup and a company for your product. And we have done that assessment. And basically, when we don't use photosynthesis, open land, there's no open land application of fertilizers, and no pesticides. Basically, in the case your electricity, what you use in our process, is carbon neutral, then you could say that the emissions what we generate are from 1% to 10% compared to plant and animal, depending upon what category you look at.
Okay, that sounds sort of very impressive figures from the sort of the ecological point of view, and I guess the ethical issues here, which are pointed out, are kind of self-evident. Safe, is it?
Well, we can claim like that because we can fully control what we put into the system, and so it's not open, it's really closed system. So we know what we put, so what are the inputs, and we can of course analyze what are the outputs. Of course we need to know our products, what we are producing, in a way that like all the new food products and the food quality and safety checking, it must take place. But in that way, this safety issues that we don't need to worry about the heavy metals of the soil or things like that, because it's a closed system. And of course we don't, if we think about now the global issue with the antibiotic resistance problem, so we don't need to use antibiotics in these processes, so that's also a clear benefit. And Pasi mentioned also the scalability, and I was referring to the brewing industry. So we really believe that these processes are scalable, and in that way also that can be seen as a clear benefit. The infra is in a way there.
Could you sort of provide an example? I mean, if I'm sort of used to, at least in my youth, I was used to seeing a lot of cows on the pastures in the summertime. So if you want to replace a cow or a herd of cows, I mean, what kind of a factory do you need to? Can you give our sort of viewers any idea of the scale of production that is needed?
Yeah. Yes. So we have actually done pre-engineering for our next step factory that we call a demonstrator. So in the past 30 months, we've built a pilot and continuously operating that, proven that, and now we want to scale to 100 times in the next 30 months. And then after that, there is a third 30-month period when we plan to build a real factory, when you compete with the price on the market. So there are huge scaling benefits. This is basically like a huge brewery, technically. So there are big tanks, basically, that dominate the view within such factory, and the technologies. The good news is that the technologies exist, so we know what those investments are. If they would be built today, so it could actually be done. And the factory, which is about 10,000 tons of protein per year, which is about 4% of the protein eaten in Finland, that would be generated by a factory that is quite precisely as a footprint similar to a football court, so 70 meters by 100 meters. And from that area you could generate. In our case, it is about 30 megawatts, 30, of power in that factory. But essentially, it's a brewery.
All right, actually now moving from factories into actually building a new industry. So basically we had in our title, we were saying, is this just magic? Which it seems to be magic from a let's say ordinary people's perspective. But could this be actually a sort of a start of a new industry, a whole new industry? So sort of how do you see it, Pasi?
In my view, that is exactly what is happening. Due to several reasons, you could claim that. One is that it's a big one of the big industrial sectors of economy globally, which is renewing. Now there are completely new technologies, not just better potatoes and maize, but or meat, more efficient or bigger animals, but there are technologies due to very fast recent technological development, completely new platforms emerge, like cultured meat is one example, or egg without chicken, and also there is a lot of capital available. So from our startup perspective, we see that venture capital industry sees food technology a bit in a similar way as they saw in late 80s, early 90s, the ICT technology, or personal computers, and later on during the past decade, e-commerce or social media. Food technology is equally, and I would say at par in a way, on the books of venture capital funds, and this basically drives from the company perspective innovation, and this has all resulted to the fact that there is a consumer pull. People are interested to the market. There is real market. The products are good. So they actually sell, there is turnover, and then that results to the fact that big companies actually start to look the sector very carefully. Simply, it just grows. The growth numbers are there, not perhaps in the classical part of the industry.
Okay, so it's not only the sort of the startups like Solar Foods. I guess you are still driving the market to some extent, but really the big companies are sort of also getting into this because they see the huge potential in this.
Well, what they look at is the growth percentages. That where does new markets appear? Where are new opportunities? And they are in the sector what we discuss here. Then they could do R&D themselves, which they do. They perhaps not. It's not much in fashion to do in-house, perhaps. But then startups is one way to innovate. To actually you buy companies that come with a new technology rather than learning by heart yourself from the scratch.
Do you have any sort of insights, Emilia, on the sort of from the consumer side that the pull really is there, and what is it that the consumers are now after?
Well, I think the timing is actually quite good for this disruption in that way, because I think consumers are already familiar with the plant-based innovations, so really finding substitutes or alternatives to meat products or dairy products. So I think they are quite ready to new things in the food market or in the food basket. So I think the timing is good, but of course I must say that this is still emerging area, and it should be studied also. I think the consumer communication and how consumers see these new products, but it doesn't really need to be that different in the end. And like you already said that if the egg it's still the same egg protein that we produce in the cell factory that the chicken is producing. So the product is actually the same. So it doesn't change necessarily.
Another view to this is that if you look at the consumer market, one way to look at it is you see kind of a forerunner companies or lighthouses. So you could say that Microsoft's and Apple's, IBM's, where that one in personal computing. Then Nokia was one in communication. And in food sector, or Tesla in electric vehicles, you needed that company to push the cluster, and I think we're seeing similar companies globally on meat alternatives, for example, and plant-based dairy.
Okay, where are these companies based? Are they? Is it like with the sort of the Silicon Valley revolution? Is California and those places also driving this revolution, or is the sort of center of gravity somewhere else?
In my view, the referring to the material what we saw before. Plant-based meat and dairy, they're a bit more equal. We do see large companies, the most famous names from the US, but it's especially in the acellular space and modified organisms. US, in my view, is clearly leading, but we do see kind of US Asian hubs leading this space in terms of financing and development and market traction. So market introduction of few of the new companies first happen there. And of course, you could also indirectly, this indicates that I'm a bit concerned what happens to the European Union. So what is our strategy in the new, when the cards are dealt in the emerging new sector in the global economy? So what do we do legally? Do we prohibit or promote and encourage?
That is $1 million question or $1 billion question, I guess, in this sense. Emilia, where are
It
we?
is $8,000 billion question.
An $8,000 billion question, $8 trillion question.
Yes.
All right. And what is the right answer for that question? Well, we'll talk about that later. Emilia, where are we from sort of research point of view? Because we're already seeing the egg proteins and the meat alternatives. I mean, is this just a case of sort of scaling up and industrializing, or are there sort of research questions still that are sort of left unanswered?
Well, of course there are, and like I said in the beginning, that this is such a broad topic that there are so many different products that we can do by this cellular agriculture concept. So in that way, I think there is just the word sky is the limit, or it's not even the limit. But of course, when we think about the first new products to the market, launching those, still I would say the scale up and the research and development related to the technology maturation and really scaling up the processes and downstream processing, and that I think it's really the core of the thing today. But then, of course, industrial biotechnology provides so many new options to complete the new things. So I think there is, of course, a lot for future to research. But I would still say the scaling up is really the key now to get the new products to the market.
How are we when we think about the consumer acceptance? Of course, one thing is that the people want to put it in their mouths. The other one is that how much do they actually have to pay for it in the market? And I guess being an emerging field, we are not necessarily sort of at par with the cost of the product. But where are we now from, let's say, cost-wise, and where do we see that actually the development and scale-up will take us? Will this be also an affordable option on top of being an ethical and ecological option?
In my view, it's not very difficult to be cheaper than meat. That's one. And simply, if you look at the plant-based space, it's very straightforward in the sense that plant-based protein and food is cheaper simply than animal-based. Then the technology development, like in our case, creates kind of a window of opportunity. You need handful of technologies to realize it. They all together can play together and together become cheaper, and then they create kind of a window of opportunity through which you can see that new opportunities emerge, like producing protein like we do. And the technological development is so fast that if it's not on that day the cheapest one, it might in a handful of years be so. And that is the principal challenge for, I would say, research, for startups, venture capital, industry, and large companies, because the time cycles are so fast. But I would say in simple terms that people will not accept more expensive food, and that is what they will not have. It will be cheaper, actually.
Yes, and we have actually done for this egg without chicken case the preliminary production cost calculations, and we were happy to see, of course it was more on the paper still, but it looks really promising. So it was very competitive actually to we are at the same production cost level compared to the chicken derived egg protein. So it looks really promising also price wise.
Okay, so that should be a guarantee that it will also sort of get through to the markets and to the masses.
I would still say, if I may, that the
Mm,
decisive factor there will be taste at the end still. So
mm,
nutritional value, maybe personalized nutrition a bit here and there, cost. There are issues that and environmental benefits are bonuses, but still taste and experience is the decisive factor if a consumer produce that product second time or third time.
mm.
So therefore, that is something that cannot be overlooked.
How do you see the balance in the future between, let's say, traditional products like, I don't know, camembert cheese and or sort of a uh, beef steaks compared to the sort of the cellular agricultural products? Do you still see a
That
market
is
for both?
that is a very good question, and you get that often. And our view to that is that there is a certain bulk of food that is eaten not in the traditional form what you described, like apples,
Mm,
camembert, or something
mm,
specific. But they are different kinds of composites, like sandwich, bread, milk as such. It's a bulk, or meals like lasagna. You have several things mixed, and it's not really
mm,
clear that it's not a steak. So that is the large bulk of calories that you can very easily influence. Then there are specific issues like certain types of cheese, wines, apples, fruits, vegetable, and there is not much need perhaps to touch that, but you could let those experience be as before. And what happens actually is that food is you could say it's too cheap globally today because you can actually throw some of it away and maybe eat just for fun. And this result perhaps in the future that you tremendously appreciate that a piece of camembert in the future more than you do today. And it might actually be then simply higher appreciated and also better for the environment.
So it's sort of like a reserved for special occasions, I guess, in that
If
case.
you need that specific texture one or
Mm,
the turkey on Christmas table, then you will have it.
mm,
But that single turkey it's not much of a problem, but it's rather
mm.
the other days of the year what you eat.
Yeah, maybe to think about the future food basket. So I see that there is a point to really go with crop cultivation on the fields, because I think it makes sense to grow plants on the fields. But of course then, like, we don't need to use those crops anymore for feed, but it can be used directly for food. So I think the
Mm.
it's just a good thing. So I see that will stay at least for a while.
So we were discussing about just before on how sort of, let's say, America, I guess North America and Asia are in a way sort of driving the both the market creation and also the technology development. But we are now in Finland. Uh, why Finland? I mean, what do we have actually? I mean, why are we discussing it here? What is the sort of the specialty of Finland that we have here? And if you could, Emilia, start to explain why Finland is an interesting place to do this.
Well, yeah, it's a good question, but and actually I was happy to see in news, was it this week actually, that the Finnish food industry is ranking top in Europe in the food innovations. So it's quite good. We are actually quite active in the food innovations at the moment, and actually it's very much acknowledged that Finnish Finnish consumers of Finland is a very good test bed to test new food innovations. Finnish consumers are very open to new things, and we can test things here. And then of course I think one critical thing is of course that Finland is a high technology country, and we have a lot of competence that we can actually make use here for building the cellular agriculture technologies.
And Pasi, you decided to start the company here and not move to Silicon Valley.
We have an excellent science-based cluster. You can say also that now kind of food technology, biotechnology, some medical aspects merge to form this new industry. So the basic knowledge is there. Also, Finland does not have perhaps so much historical burden, cultural issues on approaching new foods. So you're
So
open.
basically, other ways saying that we don't have a food culture.
It's, let's put it this way, that it's so young that you are ready to discuss about it. And then agility. So we have an innovation system where it's possible to pull together multidisciplinary teams. So it makes it a good environment to do new things and be quick and agile, which, for example, venture capital industry appreciates.
So what is the if we are looking at from the the research, we basically said that we have, of course, we have the agility, we have the cultural, the Finnish way of working actually, which is very non-hierarchical and sort of in a way very flat hierarchies, and we are used to working together. From the sort of the research point of view, Emilia, what is the sort of the strengths of the food research here in Finland, and of course, what are the sort of the strengths of our research here at VTT?
Well, it's quite a lot what I was saying already, and what Pasi was saying about the agility and really teaming up very depending on the targets. We are agile to team up to collect the best experts to do things at I would say at Finland level, but of course VTT is a multidisciplinary research company, so in that way also we can bring in the best experts. And when we talk about the cellular agriculture, of course we have a long history with in the industrial biotechnology and cell factory concepts and in food science, and now we are actually bringing in those two to really make big new things and disrupt the food system.
Now getting back to the $8 trillion question. Where do you see? What do you think? I mean, and Pasi was saying that this is really a sort of an area where the clock speed is fast, and things are moving really fast forward. So, where do you see us in? Let's say, I mean, so 10 years in this case seems like an eternity. But if you can sort of port yourself 10 years in the future, where do you think that where we could be, and what needs to be done in order to get there? So if we start with Pasi, for example, and then we'll move to Emilia.
Yeah, decade ahead. If we interpret that decade freely, it's perhaps easier to say what my grandchildren will do, or something like that. I would say, I bet that meat with killing will be a strange idea. Why would you grow all those ears and hairs and eyes if you want the meat? It's just fundamentally strange idea. In what comes to egg, it might be strange for my grandchildren to explain that we had chicken where from you stole the eggs and then you had them. It also might be strange. So that's indirect way to explain that there are some unnecessary things. Technology will change that in the coming decade, I bet. And my justification for that is that we are actually seeing the first products like this on the market today. So it's actually in the scaling phase. Then there can be Pearl Harbor events like the COVID-19. When we do this interview, we're in the middle of that, which might then the aftermath will be that you might require more transparency, including food system, and that accelerates the consumer interest to these kinds of things. So these will be scaled and on the market and start to be commodity within a decade.
Yeah, I was just planning to continue from that. I also hope to see, and I'm also of the opinion that when we are at the level that we don't actually need to do animal farming, why on earth we would do in a way that, of course, it takes time, the cultured meat and things like that. But I also see the big change. But maybe what, and I hope, like here also in the figure is shown that these legal obstacles, that we also see that European industry is a big player here, that it's really that we are competitive also in Europe. So I hope that we can resolve the legal obstacles that we have partly at the moment. And then the third thing really like is here the step 3. I really believe and I hope and believe, and really I think the future is that we still enjoy the food in a way. Like I said already in the beginning, that not much needs to change in a way, that we eat nice textures and flavors and we enjoy eating. So in that way, I see actually a very positive future.
Could you sort of elaborate a bit on looking at the scale? The first step is kind of obvious to scale up, just to get the processes to industrial scale and start producing, because I guess the amount of proteins to be replaced is large. But the step 2, can you bit open up on the sort of what kind of obstacles are we facing, especially here in Europe? What are you worried about?
Well, I think the main thing is, like Pasi said in the beginning, that in their case they are not doing any engineering of the organisms. So they are the organisms they are. So of course they have to go through the novel food regulation steps and so on. But then when we think about this cellular products, egg without chicken or just name it, so then of course we need to engineer genetically the microbes to produce the let's say animal proteins, for instance. So that's something that is not allowed yet in EU. So I would say really this GMO regulations and legislation is something that I hope that EU will revisit and adapt to the new technologies.
Okay, and that of course needs a lot of support from the consumers themselves in order to have that change, I guess. Well, I guess we are sort of coming to the end of the discussion. I guess the discussion could go on for hours and hours. And if any of our viewers is sort of interested in learning more about this, can you sort of point them in any sort of good directions where they can sort of dig deeper into the area of cellular agriculture?
Well, sure, there are, of course, many papers and presentation, and it's, I think, increasing all the time the awareness and discussion around this topic. But maybe the easiest way is to contact me and Pasi to get more insight, and then we can connect and tell you more what we can do there together.
Okay, in this case, thank you, Emilia. Thank you, Pasi. Thank you for joining me in this discussion. And as said, this was the first in a series of several SIP of Sciences that are focusing on the exponential, the list of exponential hope. And the next ones in the series will be touching things like quantum technology, small nuclear reactors, recycling, chemical recycling plastics, and also optimal use of materials. And obviously, you can also continue discussing this event of SIP of Science as any event on Twitter. So thank you for following and have a good day. Bye bye.